So yesterday we went over the different types of bonding that we've got. We reviewed how ionic is made up of a cation and an anion that are electrostatically attracted to each other. And then we had our covalent bonds, which these were when we are sharing electrons. And we discussed how a nonpolar is an equal sharing. And you can kind of think about tug of war, and those guys are pulling with equal forces. Their electronegativities are similar or the same. Whereas in your polar covalent, all of our electrons are kind of leaning to this side. And so we have this partially negative side, partially positive side. So they're not shared equally on this one. And so just another reminder, electronegativity is going to be the ability of an element to attract electrons in a bond. And so if you have a high electronegativity, you are going to be attracting a lot of them, just kind of like our B up here was, higher electronegativity. And then when they're the same, they're obviously going to be pulling the same. We like to put a big heart on this because an easy way to think of it is love of electrons. But please remember that it has to do with this ability of an element to attract an electron. We also discussed how we have something called bond polarity. And we had molecule polarity. We kind of drew it out off on the side. And so when you're looking for your bond polarity, you're focused in on your electronegativity values, and you're basically taking the difference. So if we had an OH bond, we're going to go ahead and take our O, which was 3.5, subtract the H, which is... can't really see it, sorry, which is 2.1, and we would get 1.4. Then we would look at where it falls in our scale. Like ionic is going to be anything greater than a 1.7 difference. Polar is going to be from 0.3 to 1.7. Nonpolar will be 0 to 0.3, showing that very similar electronegativities down here. 1.4 is going to fall under polar. And that's how you decide your, that's how you're going to decide what the bond polarity is. Okay. All right. And then we have molecule polarity. And that's where you're actually looking at the shape. And you're kind of, we've put it into two different categories. We said nonpolar, things look balanced, and you don't have lone pairs on your central atom. And, there's kind of some symmetry there, and all of the elements on the outside tend to look the same. So our example that we looked at was a tetrahedral. Okay, and on this, all our elements were the same on the outside. It's pretty balanced. No matter what way I turn this, it's going to kind of look the same three-dimensionally. So this was a nonpolar. Then we went ahead and said the polar ones are they're a little more unbalanced. Okay, and so we can take that tetrahedral and we can say that these are the same element, but this one is a different one. This now turned into a polar molecule. We also have an example like water, where we have lone pairs on a central atom. That just made it unbalanced as well. So those are polar molecules. So that's kind of what we covered yesterday. So what we're going to be talking about today is I want you guys to work on your lab, your pre-lab. We're going to try and get this lab in on Thursday. So if you can go ahead and turn to the very last page in your packet, okay? We'll come back and do the Lewis structures later, but what we're going to focus on is going back to our covalent and ionic properties. So I kind of told you guys yesterday, it's really important when we know these different types of bonding, because then it leads us to know, well, what's attracting it all together, whether it's electrostatic forces or intermolecular forces. And then when you look at your intermolecular forces, those have different strengths that are holding things together. And when they have different strengths, we now affect things that are shown on this page, such as your melting, volatility, solubility, and conductivity. Okay, so what I'd like you guys to do is you're going to go ahead and read this purpose, okay, so that you understand why you're doing this lab. You're going to write it in your journal. I do want you to read our background information. The only thing that I'm going to emphasize on this is I really want you to look in on when they talk about your intermolecular forces, which is right around here, okay, and see how those compare to your ionic bonds, or the electrostatic forces that hold ionic things together. So really look at that. I also want you to focus in on what these different words mean, okay, and how ionic things compare to covalently bonded things, okay. Please remember that we are dealing with not just the bonds itself, but also those intermolecular forces. So these kind of tell you a bunch of things. Volatility might be a new word for some of you. Think about rubbing alcohol. If you were to drop a little drop on a counter, it would evaporate pretty quickly. And so that's what this is talking about. And for what you guys are going to be looking for in the lab is you are going to be looking for a smell. If something smells pretty strong, and you'll know which one it is in the lab, we're going to say that's pretty volatile because it means that it's diffusing through the air very quickly, okay? Or it's turning into a gas very quickly. Solubility is the ability to dissolve. Conductivity, we're going to check that it's able to conduct an electric current, and I'll show you the little devices later. So we're going to go ahead and turn that page over. And I'm going to go ahead and kind of show you, you had kind of a start of procedures on the other side, but what we have here is you're going to have two different sets. So you have a procedure number 1, which started on the previous page, and you had 3 stations there. Then you're going to have procedure 2, and that's going to be your station number 4. So what I need you guys to do right now is you need to follow your pre-lab instructions here. So if you notice, it's just the usual name, date, title. You're going to put your purpose. You're going to answer these pre-lab questions. Okay. You're going to also create a data table. So you're going to be recording both these data tables into your journal, and make sure you're allowing yourself to record enough data. And post-lab obviously is going to be after. So really quick, if you can just kind of look with me at what exactly is going on at stations. So for station 1, it's saying that we're testing that volatility. So remember, it's basically, do you smell something or do you not? And that's what it's kind of saying right there. Okay, and that'll tell you high or low. Melting point, I'm going to actually have you put them on a hot plate, and you're going to see if something is able to melt or if it's not able to melt. And so we're going to be testing that ionic and that covalent. It's actually not in this little procedure here, but I'm going to have you guys do both. And then for solubility, you're going to be looking at whether something has dissolved in water or not. So it's pretty easy. So basically, if you see a chunk, that means it did not dissolve. If you don't see a chunk, it means it dissolved. Okay? I would like you, with your partner, and this is kind of additional, is to go through your whole list of what you've got and just tell me if it's molecular, meaning covalent bonds, okay? And you can just put a little M next to them, or you can put I for ionic bonds, okay? So if you can just do that, and so then we can have that to talk about on Wednesday, I would appreciate that. Back over to those pre-lab questions. So basically they're saying, per introduction, what are the intermolecular forces and what kind of compounds do they exist? So intermolecular forces that we've learned about, since I have your Pogles, you obviously don't have those to refer to, but if you remember, we had 3 different types. We had dipole, Okay. Dipole was only on polar covalent things. Ooh, sorry. Covalent. Okay. So that should mean a little bit more to you now that we've learned that. You also had hydrogen bonding. Hydrogen bonding was specific to if a hydrogen was connected to an F, O, or N. Okay, hydrogen bonding is fun. And then the last one was a London dispersion. Okay. And London dispersion forces was between everything that was non-polar for the most part. Okay. This is also when we had talked about squishability or polarizability. I don't feel like that's going to be a big deal on this one. If we find it is, we'll address that together. But those were your 3 types. So make sure you list those in number 1. And I kind of helped you out by telling you polar covalent, FON with polar, and non-polar. Okay. So this is also polar. All right, number 2 is saying, why do ionic compounds have such a high melting point? Remember, ionic compounds have electrostatic forces. So that's found in that introduction paragraph. Number 3 says, how will you classify a compound as having high volatility? We've answered that. Just double check your station number 1. And then number 4 says, are ionic compounds or covalent compounds more soluble in water, and why? And so I'm going to kind of leave that to you, and we can talk about this when I get back on Wednesday. But I want you to think about what water does. Water has a positive and a negative side, so water is polar. I want you to think about what that means, okay? And then finally, do ionic compounds or covalent compounds conduct electricity? And so I want you to think about when you're conducting electricity, you need charges. So which one of those 2 involves charges? That'll be it. So get this into your journal, and I will be checking it tomorrow.